Hi friends, today I am giving a lecture on Introduction to B tree. It is one of the important concepts in data structures and design and analysis of algorithms and database management system. First point, B tree is a generalization of binary search tree because in the case of binary search tree, each node must have at most two children. That means a node may have 0 children, or a node may have one child, or a node may have two children. At most, two means either it is 0 or 1 or two children. Okay. Next one. In the case of binary search tree, so each and every node has only one key element, whereas in the case of B tree, each and every node can contain m minus 1 number of key elements, where m is nothing but order of the B tree. Okay, so these are the main differences between B tree and binary search tree. Hence, we can say that B tree is a generalization of binary search tree. Okay, next, second point, B tree is a M-way search tree. That means B tree can be obtained from the M-way search tree. Hence, we can say that B tree is a M-way search tree. Okay, next one. B tree of order M has the following properties. Okay, so order M, it means B tree of order M is order 3 means M is equal to 3. M is equal to 3 means how many number of key elements are there. So number of key elements is equal to M minus 1 number of key elements. Here M value is equal to 3. 3 minus 1, that is equal to 2. So here K1 and K2 are two key elements. Next, how many number of children? Children or pointers is equal to m number of children over m number of pointers. Here m value is equal to 3. So 3 children over 3 pointers are there. This is the left pointer and this is the middle pointer and this is the right pointer. Okay. So this is the left child, this is the middle child and this is the right child. Okay. So B tree of order 3 is nothing but m is equal to 3. How many number of keys are there? That is nothing but m minus 1 number of keys. 3 minus 1, that is 2. Two key elements are there in the order of 3. Okay, so that are K1 and K2 are two key elements. Next one. So here for K1, this is the left pointer and this is the right pointer. For K2, this is the left pointer and this is the right pointer. So total how many number of pointers are there in order of 3 of B tree? So that is m number, that is 3 pointers are there. This is the left pointer or our left child. This is the middle pointer or our middle child. And this is the right pointer or our right child. So total number of pointers or our children is equal to m is equal to 3. So that means each node has at most m children. At most m children means maybe it is a 0 children or 1 children or 2 children or m children. Each node has at most m children. Suppose we are considering this B tree. So this is order of 3 B tree. So in this one, so this node contains how many number of children? 1, 2, 2 children. This node contains how many number of children? 1, 2. This node contains how many number of children? 3 children. This node contains how many number of children? 0 children. So each and every node in the B tree has at most m children. Maybe it contains 0 children or 1 children or 2 children or 3 children or m number of children. Okay. Next, second point. Each internal node has at least m by 2 with ceiling value number of children. Each internal node. Here internal node is, this is internal node. Internal node is nothing but it contains some number of children. So this is called as internal node. This is called as internal node. This is called as internal node. Root node is also a internal node. Here each internal node has at least m by 2 children. Here m is equal to 3. So that is 3 by 2 ceiling value. So that is equal to 1.5. 1.5 ceiling is equal to, that is 2. Okay. Each internal node has at least m by 2 with the ceiling number of children. So here this internal node has how many number of children? 2 children. This internal node has how many number of children? 2 children. This internal node has how many number of children? 3 children. Here at least means at least 2 children. It may contain more than 2 children. This node contains 2 children. This node contains 2 children. This node contains 3 children. Each node has at least m by 2 with ceiling value children. So here m is equal to 3. It contains at least 2 children. So this node contains 2 children. This node contains 2 children. This node contains 3 children. At least means minimum 2. Greater than 2 is also satisfied. Okay. Next one. A root node has at least 2 children. Okay. So here this is the root node. How many number of children are there? 2 children are there. This is the left child and this is the right child. So root node has at least 2 children. Minimum 2 children. Greater than 2 children is also possible for the root node in the case of B tree. Next one. A non-leaf node has at most m children and it has m minus 1 keys. Here this is a non-leaf node. This is a non-leaf node. This is a non-leaf node. Has at most m children. At most m children means here m value 3. At most 3 children. So this contains 2 children. This contains 3 children and this node contains 2 children. At most m children means it may have 1 children, it may have 2 children, or it may have 3 children. Here m is equal to 3. Each non-leaf node has at most m children and it has m minus 1 number of keys. M value is 3, so 3 minus 1, that is 2 keys. Here this non-leaf node contains 2 keys. This non-leaf node contains 1 key. This non-leaf node contains 1 key. So at most m minus 1 keys. It may contain 2 keys or it may contain 1 key. So a non-leaf node has at most m children and it has m minus 1 keys. Okay, a non-leaf node contains at most 2 children. At most m is equal to 3 children and it has m minus 1 keys, that is 2 keys. Okay. This node contains 2 keys. This node contains 1 key. This node contains 1 key. At most 2 means it may contain 1 key or it may contain 2 keys. At most m children means it may contain 1 children. It may contain 2 children. It may contain 3 children. Next point. All leaf nodes are at the same level. So here the leaf nodes are 4, 8, 20, 24. 28 and 30. So all leaf nodes are at the same level. So this is the level 1 and this is level 2 and this is level 3. All the leaf nodes are in the level 3. Next one. B tree is created in bottom up manner. So here B tree is created from bottom to top. Hence we can say that it is a bottom up manner. Finally we are getting the root node. Okay, initially we are not getting the root node. Okay, finally after inserting all the elements into the binary tree, finally we are getting the root node. So hence we can say that B tree is construction is in a bottom up manner. From bottom to top construction is there in the B tree. Next one, B tree is used for creating multi-level indexing. Okay, so B tree is also used for creating multi-level indexing. Okay, so this is called as multi-level indexing in the manner of hierarchical manner. Okay, this is one index and this is another index. This is another index. In this way, we have to go to multi-level indexing. Okay, we can observe the multi-level indexing diagram in the case of database management system. Here it is there. We have to turn in this way. First here it is there. Next here it is there. This is one indexing. This is another indexing, and these are the records. So this is called as multi-level indexing. So B tree is used for creating multi-level indexing. Okay. Next one, every node except leaf node has at least m by 2 children. So this means each internal node has at least m by 2 children. This is already discussed in this point. Okay, next one. The minimum number of keys in the root node is 1. Minimum number. Minimum number is root node contains minimum at least one key. It may contain more than one key, that means two keys or three keys based on the m value. Okay, the minimum number of keys in the root node is 1 and all other nodes has the minimum number of keys is m by 2 minus 1. Here m by 2 has the ceiling value. For example, m is equal to 3, 3 by 2 that is 1.5. 1.5 ceiling value is 2. 2 minus 1 that is equal to 1. So the root node contains a minimum key value is 1. Here minimum number of key values at the root node is 1. It's satisfied. All other nodes has the minimum number of keys is 1. So this node contains one key. This node contains two keys minimum. It may contain two keys or three keys. This node contains one key. This node contains one key. This node contains one key. This node contains one key, and this node contains two keys. Okay, the minimum number of keys at the root node is 1. Minimum 1. It may contain 2 or 3 based on the m value. And all other nodes has the minimum number of keys is m by 2 minus 1. Here m is equal to 3, 3 by 2 that is 1.5. Its ceiling value is 2, 2 minus 1 that is 1. Minimum compulsory one key value is there. It may contain 2 or 3 based on the m value. Next one. Next point, when a key is to be inserted into a full node, the node is split into two nodes and the key with the median value is inserted as the parent node. In case parent is root, then a new root is created. Okay, so for example, so here suppose m is equal to 3 is there. Okay, so now I am inserting one node. So in this one, this is a 10 and this is 15 is there. 10 and 15 is there. I want to insert 12. 12. Here m is equal to 3 means a node may contain m minus 1 number of keys. M value 3, 3 minus 1, 2. 2 keys are there. It is already this node is filled because it contains 2 keys 10 and 15. Now I want to insert 12. 12 is inserted at this place. 12 is inserted at this place between 10 and 15. Okay. Suppose we are inserting 12, then it becomes, so 10, 12, 15 is there. 10, 12 and 15 is there. But it is invalid because in the order of 3 of B tree, every node contains 2 key elements. But here it contains 3 key elements. It is not a valid node in the order of 3 of B tree. So now the median value in this one, the median value is 12. So now 12 is root node and 12 left child is 10 and 12 right child is 15. So this can be modified as this one. Median value is the parent. Here 10, 12, 15 is the median value is middle value. Middle value 12 can be taken as parent and 12 left child is 10 and 12 right child is 15. So when a key is to be inserted into a full node, so this is the full node because in the order of 3, each and every node contains 2 key elements. So already 2 key elements are there. It is a full node. Okay. The node is splitted into 2 nodes. This node is splitted into 2 nodes, and the key with the median value is inserted as the parent node. So here 12 is the middle value. It can be taken as parent, and 12 left child is 10 and 12 right child is 15. In case the parent is root, suppose the parent is root node, so then a new root is created. So suppose here one node is there, another node is there, so that here root node is new node is created. That can be discussed in the example. Okay, next one, keys are arranged in increasing order. Okay, suppose in a node, suppose there are two keys are there. These two keys are arranged in increasing order. Here 22, 26 increasing order. Here 28, 20, 30. Here increasing order. In a node, how many number of keys are there? That keys are arranged in increasing order. Okay. Next one. What are the operations can be performed on the B tree? That is insert operation, delete operation, and search operation. These are the 3 operations can be performed on the B tree. Now this is the example of B tree of order 3. So here this is root node is 18. Okay, so this line represents the left pointer. It points to a left subtree. This line represents a right pointer. It points to a right subtree. Okay, now 6 can be inserted. 18, 6 is compared with 8. It is lesser. Go to the left subtree and create a node and inserting the key value. Okay, now so here 6 is there. This is the left pointer and this is the right pointer. Suppose we are taking a node. Okay, this is 18. So this line represents the left pointer and this line represents the right pointer. Left pointer points to a left subtree. It contains the key value less than 18. Right pointer contains the key values that are greater than 18. Okay, so this is left pointer and this is right pointer. So here 6. So 6 left pointer is this one. So here 4 is less than 6. Then it can be acts as a left child. Here this is right pointer. 8 is greater than 6. So 8 can be treated as right pointer of 6. Now go to this node. This node contains two key values 22 and 26. For 26 this is the left pointer, and for 22 this is the left pointer and this is the right pointer. For 26 this is the left pointer and this is the right pointer. Here 20 is there. First 20 is compared with 22. It is lesser. Go to the left pointer of 22. Here 20 is inserted. Next 24. 24 is there. 24 is compared with 22. It is greater. Next 24 is compared with 26. It is lesser. So 24 is there in between 22 and 26. So that middle pointer can be taken and 24 is inserted into that middle pointer, that is middle child. Next one, here 26 is there. 28 and 30. 28 and 30 are greater than 26. So go to the right pointer and create a node. First 28 is inserted. Next 30 is compared with the 26. It is greater than 26. Go to the right pointer. Here 28 is there. 30 is compared with the 28. So 30 is greater than 28. Now 30 is inserted. So in the order of 3, each node has two keys. So m minus 1 number of keys, 3 minus 1, that is 2 keys. This node contains 2 keys. This node contains 2 keys. Okay. Next, how many number of children are there? M children are there. Here 1, 2, 3. 3 children are there for this node. Here 2 children are there. Here 2 children are there. At most M children, it may contain 2 children, it may contain 1 children, or it may contain 3 children. Okay. So this is the introduction about B tree. Next video we go for one example.